For our senior capstone project here at BYU Idaho, our team was sponsored by INL and Joe Palmer to create a retractable sensor for reactor experiments. Our faculty mentor was Brother Martin. In many of the reactor experiments at INL, they need to measure the temperature of the nuclear reactor. Due to the heat and radiation inside of the nuclear reactors, though, the thermocouples they use only usually last a few months. Our team was tasked with creating a device that would retract and extend the thermocouple into and out of the reactor to extend the life of the thermocouple. Our team started with concept generation. We generated concepts on how we could drive and retract the thermocouple, how to organize excess thermocouple on retraction, and how to control the driver. Our team then went through and chose some concepts to prototype and test. The concepts that we chose are highlighted below. The first prototype tested the funnel cake and how the thermocouple would act if we let it just coil naturally. We also tested how an Arduino microcontroller would work if we used it to control a roller motor using two small buttons. The second prototype was used mostly to test the MIG welder driver that we purchased. This was used to extend and retract the thermocouple and was controlled by the Arduino microcontroller. The MIG welder worked very well as a driver, so we kept that. But from prototype 1, just letting the thermocouple coil itself naturally introduced lots of kinks and tangling in the wire. To solve this, we made a spooling mechanism that would coil up the wire as it was retracted. This led to the final prototype, which consisted of the MIG welder as the driver, the spool to organize the excess wire, and an Arduino microcontroller and buttons to control the driver, shown in the box. The other components were used for presentation purposes. While we found our final prototype to be very successful, when testing it against the customer needs, we found some places that we could improve on. The two biggest things we could do to improve were increase the distance traveled by the wire. This lacked as introducing the spool increased the resistance in the motor and caused slipping on the thermocouple. It was also found that the spool itself kinked the wire while it organized it. Moving forward, some improvements that could be made to the project would be increasing the torque of the driving mechanism or reducing the speed of the driving mechanism to reduce the amount of slip in the thermocouple wire, and to possibly redesign or rethink the coiling mechanism or the storage of the excess thermocouple to reduce the amount of kinks in the wire. In conclusion, no project is really easy or perfect, but our team really enjoyed working on this project. We're thankful to Joe Palmer at INL and Brother Martin for giving us this opportunity.